Question number 8. An adult's lungs can hold about 6 liters. How many grams of air can an adult hold at a pressure of 102 kilopascals? Normal body temperature is 37 degrees Celsius, and air is about 20% oxygen and 80% nitrogen. Okay, so we're going to have to actually do several conversions here. So first, let's determine the molecular weight of air. So oxygen gas is 32 grams per mole, right? 2 times 16. Nitrogen is 28 grams per mole, right? 2 times 14. Okay, so air is about 20% oxygen, 80% nitrogen. So let's do 32 grams per mole times 0.2. That gives us 6.4 grams per mole. Okay, for nitrogen, 80%, so times 0.8. That will give us 22.4 grams per mole. So add these together, we get 28.8 grams per mole, so air. Okay, so this calculation makes sense. Okay, so let me just rewrite it. So air equals 28.8 grams per mole. Okay, we also need to convert the temperature, right? We have temperature is 37 degrees Celsius, so we need to convert that to kelvins, right? To use the ideal gas equation, we always have to convert to kelvins. So 273 plus 37 equals 310 Kelvin. The pressure is given to us in kilopascals, so we also need to convert this to the atmospheres. So it may be useful to memorize this conversion also. So 102 kilopascals. Okay, let's do unit conversion. So 1 kilopascal equals 10 to the 3 pascals, right? 1000 pascals times 101.325 pascals, 1 atmospheres. So you can always round this. The 101.325 pascals, you can round it and do an estimate, right? Without a calculator. So this equals about 1 atmosphere, actually. Okay. So yeah, so if you assume that this is 1 times 10 to the 1, 2, 3, 4, 5, 10 to the 5, right? So this is 10 to the 2. So 10 to the 2 times 10 to the 3 is 10 to the 5 over 10 to the 5 is 1. So about 1 atmosphere. Okay? So now we can calculate the number of moles of air that the lungs can hold, right? So using the ideal gas equation, we can do N equals PV over RT. So this equals about 1 atmosphere times 6 liters over 0.08, the gas constant. The gas constant has the units of liters times atmospheres over moles times Kelvin, right? And then multiply by 310 kelvins. Okay, so this equals about 0.238 moles of air. And since we have the molecular weight of air, then we can figure out the mass, right? So 0.238 moles times 28.8 grams per mole. This equals about 6.85 grams of air.